Good morning, everyone. Here now, I'm going to introduce today's speaker, Dr. Krishnanand, is currently working as an assistant professor, as professor in the Department of Artificial Intelligence at Anurag University, Hyderabad. He has over 23 years and half of teaching experience in different places. Apart from this, he has industrial experience too. He has applied a wide variety of teaching methodologies catering to students from various backgrounds in India. He has undergone Mission 10X basic and advanced certification levels. He has a special affinity towards environment and carrying out research work in utilization of soft computing techniques in mitigating the effect of greenhouse gases. He's a member of CSI and reviewer of a defense journal and a couple of elsewhere journals. His research interest includes fuzzy logic, expert systems, and evolutionary computing. May I now request Dr. Krishnanand sir to take over the charge for today's session.
Yeah, good morning, one and all. So, can you hear me, participants? Can you hear my voice? Sure. Okay. So basically, I'll be talking about fuzzy logic systems. I'll just wait for a minute. So, morning one and all. So my area of talk will basically be deal with how fuzzy logic can be used for machine learning applications. Starting with, most of you may not be familiar with what fuzzy logic deals with. Although you'll be using it every day, day-to-day life, you'll be dealing with fuzzy logic. So first, what we will tell, I'll brief you about what fuzzy logic deals with, then how exactly you can perform the operations, fuzzy logic operations, how you can carry out. Then I will then lead you towards some possible applications, some simple applications where you can do some practical work with your fuzzy logic applications, right? To start with, what does fuzzy mean? So these are the things which we'll be dealing throughout our work. The last half an hour, I'll show you a hands-on on how exactly you can do fuzzy logic operations using MATLAB, right? Okay, first thing, what fuzzy logic deals with. Fuzzy, the word itself means vague. Vague means something which is not clear. People if I'm talking about some day-to-day applications, say some work that you needs to be done or some project that needs to be done, we are not worried about the accuracy of the work. We may be more worried about getting a result as early as possible. Put a simple example. Suppose, say, you want to go from your place to, say, your house. You want to go to your house. Somebody asks you how long it will take. They don't want some huge mathematical applications where you tell that you will reach in 23 minutes, 47.85 seconds, and so on. Instead, they want a fast answer saying, I'll take 25 minutes. Your bus travel takes 25 minutes. That answer is better than putting a complex algorithm where finally you make so much research until it takes 26 minutes, 37.58 seconds, and so on. So that is where fuzzy is dealing with. Fuzzy deals with vague. How did you do? I did well. You will not say how well you do. So first answer which comes to you directly deals with fuzzy. I'll give you one more simple example before progressing further. Say you are going to a doctor. The doctor asks you, what is your problem? You simply say, I have headache. You don't talk accurate. You say, I have more headache, less headache. You don't say, I have 23 headache, 37 headache, so on. You say, I have headache. What is headache? How much pain? More headache. This is fuzzy. You are giving a fuzzy input to the doctor. What does the doctor do? The doctor takes your fuzzy values and converts to real values. The doctor performs tests. Doctor converts your fuzzy values to real values. The doctor takes blood pressure. The doctor takes values. The doctor is able to do experiments telling the value is 72, 85, all these values. Finally, what do you want the doctor? You don't want the values again. You don't want 72, 85, blood pressure is 72, all these things you don't want. You want the doctor to say, you take these medicines, you will be all right, or you will be well. You don't want doctor to say, earlier you had 72 headache, now you had 23.59. This is the improvement. All these numbers you don't want. You simply want, you will be all right. Your headache will reduce. Not reduce how much, reduce more, not the values. Such cases where all these applications where you need speed rather than accuracy, we will go for fuzzy logic. The second place where fuzzy will play a very important role, where your day-to-day models, you may call neural networks, you can call all these neural, whatever convolution, all these things will fail, is place where there are uncertainties. Suppose some input values are missing. I don't have those inputs. Your neural networks will fail completely. It will say no inputs. It will give a wrong value or it will give you. Whereas if you go for fuzzy, it will still give you some values. Even if some values are missing, you have an answer, right? So first thing you should know when to use fuzzy logic. After listening to this lecture, you should not say, whatever I do, I will do using fuzzy logic. First, you should be clear with what is needed. So I've just put into three categories. That is, one is a mathematical model, one is fuzzy logic, one is a neural network. Now say, suppose you take a system, any system. A system will have inputs. It will have some outputs. The inputs and outputs will be connected by some formula. You can say e power x into power of x. Any formula you take, some formula may be there. If you know the formula already, you know this is the formula, you can develop what is called mathematical model. Yes, this is the input. I use these equations. I get these outputs. No neural networks, no fuzzy, nothing is needed. I know the inputs. I know the outputs. I know the formula. This is the first case. Second case, I know the inputs. I know the outputs. I don't know the formula. Some formula may be connecting. I don't know the formula. And formula is not easy to guess within minutes or hours, whatever. You need to do law iteratively. You need some complex computers to make some calculation. Formula may not be a very simple formula like multiplication or something. Some complex formula. It may involve Laplace. It may involve power of something. I am not able to find the formula. I don't know the formula, but I know if I give these inputs, I will get these outputs. If I give these inputs, some other outputs I get. All these things I know. How to find the formula? To find the formula, the easiest way what you go for is a neural network. So that is the purpose of a neural network. I know the inputs, I know the outputs. I want to find the formula. Once I find the formula, what happens? Whatever inputs I get, I can predict the outputs. Neural network. That is what plenty of research is still going on. Neural networks. Now, if you have images, you go for convolutional neural network. Everything is excellent. But even a neural network, you need inputs and outputs. Suppose I don't know some input is missing, or output is missing, or I don't know the exact value of input or output. I will say the input is maybe, I don't know, it is 72 or 73, it may be some value. I don't know the value. Some inputs I don't know. Your fuzzy logic will give an answer. Some values are missing, it doesn't matter. I will give you an answer. Best example, you go to a factory, they need continuously, one person will monitor how much oil they have put and so on. One time they don't monitor, they forgot. The operator forgot to monitor. Your neural network will say some missing value and it will fail. Your fuzzy logic will be able to predict what could be the missing value, or even without a missing value, it will predict your outputs. Leave alone missing. Suppose instead of 10, by chance you put 1,000, some other value you put, some outliers are coming. Your fuzzy logic has an answer. So places involving uncertainty, places involving vague data. Why I say vague? Okay, here we have some people. He's a tall person. What is falsification? Say you are having a real value or crisp value as we call, say 5 feet is a crisp value. Convert it into a fuzzy value. The height is medium. The height is tall. Converting a crisp value to a fuzzy value, we call falsification. Then what is defalsification? As you all would have rightly guessed, converting a fuzzy value to a crisp value. Finally, the blood pressure or some value the doctor gets is 75. He will not tell it is 75. He will tell this is normal blood pressure. You are normal, perfectly normal. So he wants to tell from what that is falsification. From normal, say from a word like normal, converting to a number is defalsification. So throughout the process, we will carry out fuzzification and defuzzification. Your input will be fuzzy. You will defuzzify. Then you will perform operations, calculations, fuzzy calculations. We'll see some examples. And finally, again, you will convert it to a fuzzy number. Those are the operations. Sample operations we will be seeing. We will also be seeing an example how you can do with your limited knowledge, how you can experiment it. I'll show it in MATLAB. MATLAB is a wonderful tool which can handle any kinds of applications. One fuzzy tool it has that we'll be showing during the last half an hour or something. So first, before you see MATLAB, you have to understand the operations. Next thing I told you, we have converted to fuzzy. Fuzzy is not, fuzzy also we have values between 0 and 1. But fuzzy is not probability. In probability, event is definitely happening or not happening. Event cannot partially happen. Final answer is true or false. You only say how much chance of true, how much chance of false. There is nothing in between. Whereas fuzzy, we introduce a concept of membership functions where you have an in-between value. Why do you need in-between? Real world is talking about in-between values. Say, for example, you say, if you use your normal Boolean logic, you have only true or false. I will ask you a question. Are you tall? What is your answer? So some person is say, I'm 5, you suppose say, above 5 feet 10 inches is tall. One person is 5 feet 10.5 inches. So you can say it is tall. Okay, good. Now suppose a person is 5 feet 9.5 inches. Both of them look almost same. Your Boolean will tell, no, it is less than 5 feet 10 inches. You are not tall. They'll give 0 for 5 feet 9.5 inches and definitely true for 5 feet 10.5 inches. From human perspective, this is very awkward. A small change in value, you're completely saying things are false. But real world will not function that way. So what you should say? 5 feet 9.5 inches. Okay, you cannot say that definitely tall. You will say it is 95% to the degree of tall, very close to tall. So you give a number, say 0.95. 0.95 is a degree of membership. What extent it is tall. That much you are. Suppose it is 5 feet 8.5 inches. I will give some 0.6. That means that much degree it is close for under the category of tall. 6 feet, definitely tall. Give the value 1. 5 feet, definitely not tall. Give 0. Definitely false, 0. Definitely true, 1. Very close to true and all, you give some values. Who will give the values? We will give the value. We will assign. How do we assign? Think what people will think. Think of the real world. You have to use your common sense. We will formulate the values. You can, after formulating the values, you can test. Then suppose you think it is not working well, we will change the values. We'll keep on trying, change the values, see how well it functions. So the third concept which we have introduced here is what is called membership function. It will talk about degrees of truth. The last point you can see on the slide, degree of truth. How much true it is, what extent of truth it is. Definitely true is 1, definitely false is 0. Degree of truth, if it is close to 0, very small degree. More closer to 1, very high degree. So the third thing which we have defined, membership functions, as we can call. So these are some sample applications. One of the applications may be control system or something. I can demonstrate in the end how one sample we can show in MATLAB. I can demonstrate and show this some sample. Instead of these applications, you take any application. which deals with uncertainty, we can use fuzzy logic. These are all just sample applications. You have hundreds of applications. So as we discussed so far, our major area of focus is one is problems involving uncertainty. I said something I'm not sure whether this will happen or not. So it is not same as probability, uncertainty. Okay, can I call this some particular extent call whether some event will happen or not? I'm not sure. Is uncertainty. For probability, you have some ways of telling how it is 0.6 is based on the weather and all, you give one value. Extent, here we say how close. So here the purpose is we concentrate on fast approximate solutions. I want an answer very fast. You want doctor to fast, tell you fast, please take this and so on. You'll be all right. Rather than telling, your BP will reduce from 72 to 73.7 if you take 0.5 of this tablet. If you take 0.7, you don't want all this. You want something, you do this, I'll be better. How much better? More better, less better. Not 7 better or 8 better. Right? So, fast, approximate solutions we require with respect to fuzzy logic. Now, you may ask me, no, in my application, I want accuracy. Accuracy should be perfect. Measurement, some aircraft length, width I'm measuring, it should be accurate. How should I do with fuzzy? I'll tell you one simple answer. You want very accurate answer? Please don't go for fuzzy. Please take an application where accuracy is given an importance. We are concentrating on something where you get a solution which is very fast, and most of the applications in real world deal with high speed rather than accurate. That's why I gave you an example. Okay. Now, how do you want to define a? So now we will need to deal with some few mathematical operations. We'll only deal with simple mathematical and logical operations. We will not talk about very complex things. A logic operation which even an 8th standard or 9th standard can understand. And, or, not, and so on. Right? Only when you understand this, when I show you the application, you can picturize better. Right? So first we have just told about what is the difference between max and fuzzy. So I also told you what is fuzzification, what is defuzzification. Fuzzification, crisp values should be converted to fuzzy values. Crisp is definite, 7 feet, convert to tall. Fuzzy to crisp, defuzzification. Third aspect we need to do is, we have to generate rules. Ultimately, you want to do an application. I want to generate some rules. So for that, what we need to do? Before that, we need to talk about membership function. So I will tell a rule. If person is tall and person is not fat, he can be selected in basketball team. This is an example of a rule. If person is tall, that tall is a fuzzy value, and is the operation I'm giving. Person is tall and person is not fat. Not fat is again, not is again a logical operation. Then selected to bas. So the entire thing we call it as rules. Our rules, we are only going to talk about simple rules with if-then statements. Since all of you, even if you are not of computer science background, you may be familiar with some programming language. What is if-then? That may be familiar with all of you. Even if you are a electronics graduate or even if you are a mechanical person, whoever you are, simple if-then. We are not going to do coding. You all understand what is if-then. If A, then B. That A, we call it as antecedent. B is called consequent. So far you will only tell if A, then B. But the problem is you don't know the meaning of what is A, what is B. Here you should know the meaning. If your friend comes to your house, then you will go to a movie. If A, then B. If both of these events happen, then you will go to the park. If A and B, then C. So day to day, you'll frame you'll have plenty of rules. Put all these rules in order. You have to frame the rules. Before framing the rules, you have to give a membership. So if the person is tall, so what is tall? You have to define. Above 6 feet is tall. 5 feet 10 inches. 0.8 to the degree of tall. You will give some values. I will show you those things. Then after rule generation, after formulating rules, so as we told, these are the 3 steps we are going to deal with. Any problem? Falsification, rule, evaluation. You have to evaluate the rules. What are the rules? We have just told. Then defalsification. So translate input into truth values, compute output truth values, and transfer truth values into output. So falsification, rule evaluation, and defalsification. Only so your input is, you're getting some input, you'll get some output. Suppose your input is fuzzy and your output is fuzzy, we will reverse the process. First you will do defalsification, rule evaluation, again we will do falsification, right? So these steps can change depending on the problem. But the 3 processes are same. First and third we can interchange if needed by the problem. Okay. Now I'll show you starting from a very simple example. Now I'll take in the first thing here. I want a set of real numbers in the range 5 to 8. If the number is 5, output is true. Number is 6, output is true. Number is 7, output is true. Number is 8, output is true. All the others, output is false. This is like a normal Boolean logic. Up to 5, membership value is 0. 5 to 8, membership is 1. From 8 onwards, it is 0. This doesn't have many fuzzy aspects. It is having just, there is no value between 0 and 1. Similarly, set of people taller 6 feet or more. If I have defined like this, 6 feet or more, I'm giving a crisp value here. So up to 6 feet, it is 0. More than 6 feet, it is 1. This is something you have all done in your day-to-day exercise or lab exercises, wherever you are doing. It is either 0 or 1, nothing in between. But for fuzzy, what is in between is very important. Without that, there is no fuzzy. So here, now what we are talking, I want to talk about tall. In this case, what did we do? Above 6 feet is tall. What is the problem in this? You are telling 6 feet is tall. 5, 11 and a half feet? No, not tall. Straight away you are saying, no, not tall. Which does not make common sense. There is no common sense. 6 feet, yes, definitely tall. 5 feet, 11 and a half, definitely not tall. Absolutely no common sense. This common sense we want to introduce. Which fuzzy will introduce? Which your other applications, normal Boolean logic, will fail. All these applications, you can go for fuzzy. Now here what I have done, I have given a continuous membership function for tall. Yes, above 6 feet or some feet, I say 6 feet 2 inches, definitely tall. I put definitely tall. What about 5 feet 11 and a half inches? Very close to 1. Yes, very close to this tall. I'm not saying not tall. It is having a membership of 0.9 to the extent of tall. 5 So what we have seen here is, we are seeing this is an example of a continuous membership function for top. You can also have a triangular shape. This curve can be a straight linear curve, or the curve can be a trapezoidal. We have so many. We'll see some 2-3 examples. This curve, you can ask, what curve should we put? You don't know. So use your common sense and define some values. 5 feet 9. How much you want to give? Think. You want to give 0.5? Give 0.5. You want to give 0.6? Give 0.6. 5 feet 7 inches. Give some value. Plot the points. Put all the points together, join it. Whatever curve you get, that is your membership function curve. You can define the membership function. There is no hard and fast. No, I showed continuous membership. I showed sigmoidal. I am not getting sigmoidal. You see what you are getting for your example. That's why we will define some standard curves. MATLAB supports some 8 or 9 standard curves like sigmoidal, triangular, bell-shaped, trapezoidal, some standard shapes. If you want some other shapes, say MATLAB may or may not support, you can do your own code. Once you become an expert, you can define your own shapes. But majority, whatever is commonly used, MATLAB will support. Right? So this is an example for height, suitable for fuzzy. So here you see, really not tall or definitely tall person. All these things we can define. Okay. Now as here, okay. So here I have given 2 membership functions, 0.95 and 0.3. 2 different heights, both have some degree of tall. Next one. Now we have, so far what have we talked about? We have talked about inputs, outputs, and in between inputs and outputs, we have the model. Then we have defined the membership function. What is a membership function? What is fuzzification? What is defuzzification? Next thing is, inside we have a model. So if you want to know what is it, okay, we will first part. Okay, let's come back. The model, how you are converting input to output, can be either Mamdani or Sugino. There are some more. These are the 2 most commonly used models in our fuzzy logic, right? So whenever some intuition is needed, you want to use some creativity and try to identify a formula. Any creativity is needed, we go for Mamdani. Suppose the inputs and outputs are connected by some mathematical formula, some linear order is there, some mathematical aspect is there, we can go for Sugino. So suppose a particular shape, say for example, you want to go from place to place. You travel 2 kilometers, this much time, 4 kilometers, this much time. So as and when you progress further, there is some linear mute. Okay. So as I told, your Mamdani is intuitive. Intuitive means you have to create, some creativity may be there. And it is well suited to human input, because human behavior is something which you may find aspects where you don't want to form formulate a specific mathematical or linear application. Whereas if you go for Sugino, it is suitable, it is more efficient. So first answer, I want more accuracy or something. Your Sugino models, your accuracy will be much better. And it is suitable for mathematical analysis. Example like PID control. Ball is moving, how much I have to control. So you have a specific level with which your value should change. We can go for Sugino model. Mamdani is completely creative. At that moment, some intuitively, at this suddenly a new event happened. How to act on it, Mamdani will give you. So depending on your problem, we can either go for Mamdani or you can go for Sugino. Right? Now, next thing what we are talking about is, we will talk about some sample membership functions. So if you talk about one example, triangular, trapezoidal, bell-shaped, sigmoidal, or your own, you want to define various membership functions. I'll show you these examples, right? So what is a membership function? I already told you. Now I will take a case of a trapezoidal membership function. So I want some values I'm giving. A, B, C, D. I have to define 4 values. Suppose I want to talk about medium height. When is the height medium? You can say from 5 feet to 5.5 feet is medium. Definitely medium. So 5 feet may be B, 5.5 feet may be C. So 5 to 5.5 feet is definitely true. So if you see the graph, I'll see from B to C, you will find the value is 1. Of course, 1 is not shown there. The top of the trapezium value is 1. The bottom line is 0. Medium height from A to B, below 5 feet, I will not say not medium. I will say 0.7 to the degree of medium, 0.6 to the degree of medium, and so on. Below a value of say 4.5 feet, definitely not medium. So below A, definitely not true. Below D, definitely not true. Sorry, above D, definitely not true. Between B and C, definitely true. So place between A and B and C and D will have the membership values between 0 and 1. And these are the sample membership functions which we have. Trapezoidal, G bell, P sigma, D sigma, sigmoidal function, Gaussian. All these membership functions are supported by MATLAB. These are the shapes taken by different membership functions. People who want to do research on this or projects, if you feel the values will change according to one of these shapes, you simply define the shape and give the values. The MATLAB will automatically plot the functions. You need not even write the function. But if it doesn't match any of these shapes, then we can come back to, we can define our own shapes and we can go ahead. Okay. Now we will see an example here. I said we will perform simple operations like A and B, or say X and Y, as you have pointed out. X or Y, not X, minimum of X and Y, maximum of X and Y, and 1 minus X. Because the membership value will be normally all Okay, there was some disturbance. Okay, so we will be taking some sample examples like a fuzzy interval between 5 and 8, a fuzzy number about 4. About 4 means around 4. Around 4, 3.8, you can say around 4, 3.7, around 4. The extent to which it is close to 4 will change. 3, I will definitely say, or 2, I will definitely say is not about 4. So like that, we want to perform, define the num, and we want to perform operations like A or B, A and B. These operations we want to perform. We will now see how we will go about this. Now, first what did I tell? A is a fuzzy interval between 5 and 8. So what you find? 5 to 8, the membership is definitely 1. Yes, it is 5 to 8 is 1. Very close to 5 and very close to 8, I'm defining values 0.9, 0.8. So I've defined like a trapezium. This is a trapezoidal membership function. So if you take a value here, say 4.5, below 4.5, membership value is 0. Above 8.5, again it is 0. So between 4.5 and 5, and between 8 and 8.5, our membership values are changing. We are giving some values. So we have defined like a trapezoidal function. Second one, B is a fuzzy number about 4, around 4. That means 4 is definitely true. Any value close to 4, we will give some value. Away from 4, we will give 0. So 4, you should have 1. Away from 4 is 0. Close to 4, some value. How close it is to 4? So we have defined a triangular membership function here. For 4, it is true, 1. All the other values, not 1. Away from 4, it is 0. Now this is, my first one is A, second one is B. I want so like we will take so A is 0, B is 0. So what you find is A and B will be 0, A or B is 0. Very good. Like Boolean algebra, excellent. Up to 3 or 3.5, both A and B are 0. So A or B will be 0. A and B will also be 0. Now, if both are 1, then also you can find A or B is 1, A and B is 1. Now, what will happen at, say, 4, at the value 4? At the value of 4, your A is 0, B is 1. So 0 or 1 is 1. A and B is 0. So one value is 0, one value is 1 is also fine. Now the trick comes when one value is 0, sorry, not 0, one value is between 0 and 1. Other value is also between 0 and 1. Say A is 0.5, B is 0.7. So how to find A or B? So A or B will be maximum of A and B. A and B will be minimum of A and B. When values are 0, minimum is 0. Values are 1, maximum is 1. When value is in between, we will take minimum for AND, maximum for OR. So now when we see the next slide, you can see here, this is A U. This U means union. Union stands for OR. A union B. So when you see the previous up to 3.5 or something, both are 0. After that, my value starts. So the one on your violet, that violet color curve, which you can see, is A or B. When you see A or B, we will find the maximum of the two curves we will take. Above 8.5, it is 0. Below 3.5, it is 0. Because both are 0. Other values, we will take the maximum. This is A. A or B is nothing but A union B. Similarly, next one, we want to perform A and B. A and B is, we want to find the minimum value. So next graph, we will see A and B. Whatever is the minimum of the two curves, you just see the violet part. This is the function for A and B. The green one is A, that brown one is B, violet one is A and B. This is how we find OR and AND operations. The third important operation is NOT operation. NOT means what? A is true, B is not true. For NOT operation, for 0 it will be 1, 1 it will be 0. But for in-between operations also, we can find NOT. What is NOT? 1 minus of that operation. You can just see here. Next. Okay, we will just show you that. So not, maybe in the next part we will be seeing. So NOT means whatever is 1 minus of that value will come in that. If A membership is 0.3, not A membership will be 1 minus 0.3. So next thing is few concepts of fuzzy we need to learn. So these concepts will be useful if you are performing any membership. Okay. So these concepts we are going to start with. So first one, we will talk about support. So any place where the membership value is more than 0, we will call that as support of the fuzzy set. My membership value is greater than 0. It can be 0.1. Support. Second thing is core. First thing what I told you is support. Support we will have for all the points where any membership value you have, it should not be 0. 0 means it is not true. 0.2 means some extent it is true. So that will be part of support. Any membership value greater than 0, So below I've shown you a curve. So from x1 to x2, all the values, you are going to have some value of membership. So my support of A will be from x1 to x2. Membership value should be greater than 0. The second concept is core. Core means my membership value should be 1. If it is even slightly less than 1, it is not part of the core. All the values. So I've shown you a trapezoidal membership function here. From x1 to x2, the membership value is 1. So the core will be from x1 to x2. What is the support for this? The starting point of the trapezoid to the ending point of the trapezoid is support. x1 to x2 here will be the core. So mu is a standard term we use for membership. So mu A of x is equal to 1. That part we call it as core, because these are some of the concepts which you should know whenever you take up any fuzzy projects. Next, crossover point. Because as my membership function, you take any curve, whether it's a bell shape, sigmoidal, triangular, trapezoidal, G-bell, Z shape, the values will go from 0 to 1. Right? Okay, so we have talked about crossover, and we have also talked about, so we have talked first about support, core, and crossover. Third thing we are going to talk about is what is the height of a fuzzy set. So height of the fuzzy set is the highest point which the fuzzy set will reach. All the membership functions which we have seen so far, the highest point is 1. At some value, your membership is 1. If membership value is 1, it means it is definitely true. If it is definitely true, then the height is 1. But suppose we have a fuzzy set where height you just see here. I've shown 3 fuzzy sets here where A, B, and C. A, you find the topmost peak has a membership 1, whereas B and C, they are never completely true at any value. So for B, the maximum height is 0.4 membership function. So we will say height is 0.4. If I say height is 0.4, it will never cross the value of 0.4. For C, the height is 0.75. So if the height is less than 1, we call the fuzzy set as subnormal fuzzy set. It is not a normal fuzzy set. Normal fuzzy set should have a height of 1. Some point it should be definitely true. Subnormal fuzzy set will never reach the value 1, whatever the case. Suppose you want to define very tall something. Whatever height you give, you can definitely say it is not 100% true. Then we will say it is a subnormal fuzzy set. Normal, as I told, normal means you should reach the value 1. Whenever whatever values you reach the value 1, we already said we call the term core. Set of points where the value is 1. So if the core is empty means there is no value when you reach the value 1. So what happens? So a fuzzy set is normal if core is not empty. So in this triangular membership function, if you see, you can find core of A is x2. At x2 point, you are having value is 1. So this is a normal fuzzy set. Core is not empty. Next concept, fuzzy singleton. So the point at which, if there is only one point at which you have a value of the fuzzy, only one point. All the other points it is false, nothing is there. We call it is a fuzzy singleton. At that value, it is 1. So my core should be 1 at only one point. All the other points, I'm not going to have a value. So this is an example of singleton. Okay. Now comes the next concept. This is one aspect where many research projects will be leading to. So if anybody is interested in research, this concept is important. Research can be even doing some projects where you deal with some cutoff values, normally in control, motor control. We need a concept. One is called alpha cut. So I want to define a values only about, suppose you want to define tall. We have membership values from 0 to 1. 1 is definitely tall. But even 0.9, 0.8 you want to consider. So you can define one cutoff point. Above membership function 0.6, I will consider. Even day-to-day life you use, not for fuzzy. Say people who want to take up, maybe students who want to take up placement. Above 70% you are eligible. You want to have a cutoff. Pass mark maybe even 40 or 50, but only above 70% I want to allow. Only if the person is at least 70% to this extent. For basketball teams, I want height above 6.5 feet. But anybody who is having 0.7 membership function or more, I want to consider. I will use a concept, what is called alpha cut. Okay. For convexity, you should know the concept of what is monotonicity. Monotonicity means consistently the things will increase or consistently it will decrease. It will not increase and decrease and increase and decrease. Once you can increase continuously, once you can decrease continuously. But if you increase and decrease continuously, the system is not okay. The one on the right, it increases, decreases, again it increases, again, no, not allowed. That means it is not convex. So here, if you can see in the left, one on the left, From x1 to x2, your increase is coming. Then after that, there is a decrease. Only once. It is monotonic. Monotonically increasing means consistently increase, never goes down. After that, monotonically decreasing. That means it should not go up and down. The second one, you can see it is going up and down. It is not convex. Because why I'm showing you the graph is, I can tell you with the formula, at this stage, it will be difficult for you to follow the formula. So if I show you the graph, your understanding will be better. Once you go into your research aspect, then we can introduce this formula. Next, what is a fuzzy number? So two conditions it should satisfy: normal and convex. We have already discussed this. As a recap, you can think, what is normal? Normal means I should have, at some point at least, the value should reach 1. The value should be 1. So it's a convex. Convex means it should not go up and down. So second one, the one on the right, it is reaching 1, but it is not convex. If it is not convex, it is not a fuzzy number. If it is not normal also, it is not a fuzzy number. So two conditions for a number to be fuzzy number. Because later when I show, I want you to represent a fuzzy number. You should know that at some point value should be 1, at least 1 point. And there should be only 1 increase and 1 decrease maximum. So normal and convex, we call it as fuzzy number. So here again, for you to understand, I've shown 3 examples. The first example, A, increases once, decreases once. So what do you find? You find it is also reaching the value 1. So we can say it is a fuzzy number because it is normal and convex. It is not. Second one, you take B. B also is reaching 1, increases 1, decreases 1. It is a fuzzy number. C is not a fuzzy number. Why? It is convex, but it is not normal. So any of the two conditions are not satisfied, it is not a fuzzy number. So in any problem, if fuzzy number has to be input, you should cross-check these two conditions. Has it reached 1 at any time? Is it convex? This is what I told you before. I want to find the NOT operation for a fuzzy set. For finding the NOT operation, I will go for complement. I want to do complement of the operation. So complement means, normally in Boolean algebra, 0 complement is 1, 1 complement is 0. But here we have membership values between 0 and 1. So what we have to find? We have to find 1 minus of that value. If some event is so this is how we demonstrate the complement of a fuzzy set. Now for you to understand the other concepts further, we will take this A membership function. Now, what is the core of this membership function? It is not shown. We have already discussed before. What is the core? What is the definition for core? my membership value, the set of values where membership value is 1. If you see up to that 1 or 1.5, it is true. So 0 to 1.5 value of X is the core. Next, what is this support? Support means values where membership function is greater than 0. So up to 3, it is greater than 0. Only from 3, it is 0. So 0 to 3 is my support. Now my third thing. What is the third thing that I have? I want to know whether it is a normal fuzzy set. Is it normal? Yes, it is normal. Why? I reach a value 1. I have some core is not empty. It is normal. Is it convex? Yes, it is convex. It is only decreasing once. It is not decreasing and increasing. It is convex. So this is an example of normal and convex fuzzy set. So I can call A as a fuzzy number because it is both normal and convex. Right? So we talked about complement. Now we go to the next step. We have now defined how to define a number, how to define A, how to define B. Now we have to talk about A and B also we have defined. Our next thing is we have to go for rules. If A and B is true, then C is true. How to define A, we have seen. How to define B, we have seen. How to define A and B, we have seen. Now, if A and B, then C. How to define? Normal. So if P then Q, so I know P is true, then automatically you will say Q is true. In fuzzy, when we say there is no definitely true or definitely false, so we are slightly modifying. If P then Q, mostly P is true. Your conclusion should be mostly Q is true. This mostly, this is the vague fuzzy term we have introduced. In our rules also, we are introducing. These two we have already discussed. Maximum, how do you find union? Union, we will deal with the maximization, which is the OR operation. Intersection is the minimization, which is the AND operation. So these are some rules. We have already discussed many. We can discuss just one or two more, 2 or 3, which are more important to us. So 2, 3 differences between a fuzzy and a Boolean algebra. In Boolean algebra, A intersection A complement will always be null. A is true and complement of A is true. Answer is null. Whereas in a fuzzy set, A complement, say A intersection A complement will not be null. It is true to the extent 0.3. It is false to the extent 0.7. True and false to the extent of minimum of 0.3 and 0.7, which will be 0.3, which is not 0. That is one difference. This is the law of contradiction. A and A complement will not be null. It will have some value. Second one, we can talk about your law of excluded middle. Either A or A complement will always be true for a normal set. Either A is true or A complement is true. A or A union A bar will be universal set. Whereas in fuzzy, A union A bar will be maximum of both. 0.3 and 0.7 means I'll get 0.7, which will not be the universal set. This one, we call it as law of excluded middle. Third one, absorption. We will say A union of A intersection B is A, and A union of A union B, this is A. Absorption of complement, this will not be true for fuzzy sets. Anyway, when we see an example, you can understand this better. So now what I'm going to talk about next, we have so far, we have defined how to define a membership function, how to define the inputs, how to define the outputs, how to define the rules. Orally, we have seen. Now what I will show you is, I will show you some aspects, how things change. Things change from, say, I want we will now take a process here. So I have a controller. I will give some inputs. Some process takes place, any process. What is the process? Your own experiment can decide. I'm not interested in what your experiment is going to do. Some process is there. We will make some measurements and we want to make some adjustment. Something like valve is leaking. I want some water to flow. Even if you take a tap, you turn a tap, you want to flow to slow down. What do? You slightly turn the tap. You don't close it fully. Slightly turn so that approximate amount of water will come out. So based on the amount of measurement, you have to decide how much you want to turn the tap. You fully turn the tap, no water will come. Fully tap, full quantity. I don't want full quantity. I want some quantity, which is a fuzzy quantity. Based on the measurement, I'll say, if I turn like this much amount of water is falling. It is 20 ml. No, I want 16 ml. So you adjust how much angle you have to turn the tap. You have to make some adjustment. Again, you check the process. This is some application which is a fuzzy engineering aspect. So here if you see, this oh. Now we will again take some aspects here. So I'm now considering 3 parameters: relative humidity, temperature, and heat index. So the relative humidity, say now I have a value 74, temperature is 25, heat index is 25.5. Now what is the first thing we need to do? We want to fuzzify the inputs. That's 74. I'm converting to mid. Temperature to mid. Heat index is high. I want to convert. So this is a function of relative humidity and temperature, converting it into heat index. So as showing a function, we are doing this specification. So you are using this. Next, we have to formulate a rule. So next, I'll show you a rule. This I will show you little. I'll show you when I come to your MATLAB, how do you do. So now we want to say some particular range. I want say my range value should be 0 or 3. Now, next thing is we want to define which are the inputs, which are the outputs. Suppose, for example, relative humidity is an input, temperature is an input, heat index is an output, just for example. So that is what I've given here. What can be a rule? I can say, if relative humidity is mid or medium and temperature is medium, then heat is high. This is a fuzzy rule. I can also frame another rule like, if relative humidity okay. So I'll just show what example we are going to discuss. Then I'll go into your MATLAB and show how exactly you will do. A very simple example. This is not an industrial example. I've given this example so that any participant from any background can understand, starting from an 8th standard student to a very elderly person, right? Okay. Now, what I've done, I'm considering a very simple example. There are two inputs. Many of you may have gone to a restaurant. You go to a restaurant and you eat food. After eating food, what you want to do is you want to give some tips. So you consider two parameters. Our voice is audible now? Yeah, fine. Sorry, ma'am. Okay. Okay, now. So, okay, fine. I'll just again brief it, what we had told earlier. So what we are now doing is, I've just taken a very simple example where anyone can understand. So I've gone to we're going to a restaurant. Based on service and quality of food, I would like to choose how much tips to give. So you frame your rules. First, you have to frame. That's why you have to intuitively frame. Because when you're doing a project, your role is just frame the rules and give it to the system. Give it to your MATLAB. That will generate the outputs. As a human, our role, we please some example of rules I've told. If service is poor or food is rancid, then tip is cheap. Another rule. So you keep on framing rules. One rule may not be enough. If service is good, tip is average. So I've given some sample rules here. All these things are fuzzy rules. The reason why I say it is fuzzy is you're not telling service is 75, 35. You're saying service is good. Good is a fuzzy variable. Tip is average. It's a fuzzy variable. Right? So for this, what we are going to do is, I'm going to demonstrate, possibly I'll show you how exactly we can carry out these things through MATLAB. Right? So this example, we can check it out. So first, what is our first step? We have to define what is called the antecedents. Antecedents is the things based on which your output comes. So service and food are our antecedents. Tip, that is going to be the consequent. So, if you say if condition, we don't use the word condition. We will use the word antecedents. What happens is the consequent, right? So now I'll just, just give a break for 2-3 minutes. I'll switch over to MATLAB. I will show you how exactly you will be feeding this. Just 2 minutes. This screen. Hello? Yeah. Okay. So first thing what we do is, you open your MATLAB. It will show your command prompt. Right? So I hope you can see the screen. So in the command prompt, you normally do other operations. So this is immediately after opening MATLAB, you'll see a double arrow. People who are familiar with MATLAB is fine. So as soon as you open your MATLAB, when you get the double arrow, you just type the word fuzzy. Right? This will open the fuzzy toolbox. So when you go to fuzzy, the screen is visible. So when you open, this is the screen which will be shown to you. Not coming? Okay. So when you open fuzzy, the screen will come in. So the moment you type fuzzy and press enter, this screen will be shown to you. So all of you, you just see the screen. So what are the things you can see here? First, you can see what is the one word that is there, input. Then you can see some system where it is showing within brackets Mamdani. There is no name because we have not defined anything. And some output. It simply shows input 1, Mamdani, output 1. Now, what is our step? What are our inputs? We will take the tipping problem example, where our input is food quality and service. And output is going to be tips. And for each of them, we should define the membership functions. That is what we need to do. So before you use the screen, you keep the values. What values you want to keep membership? You can note down a sheet of paper or something. The moment you come inside, you can feed the values. Now we will click the input. You can click here, you can click output, or you click input. Now I need one more input. So what I will do, I will go to edit, add variable, and give input. Now when you click input, now you see there are two inputs now. Input 1, input 2. But I don't want the word input 1. What is that input 1? Click input 1 and give whatever name you want. I will now put quality of food. Food quality. Whatever name you want, you please define. Food quality. I will define. The name will change. Again, input 2, I'll put it as service. Again, name will change. Now, output also, you click, you remove the default name output 1 and click tips. After that, it changes. Next, if you want, the system we will see little later. Now, food quality you have defined, but random this one. So we will see here rancid. I will just give the word rancid. Next, I will for rancid again, we want to define values. We have to decide what membership I want. I want triangular membership, choose triangular. Trapezoidal, that you have to keep it ready. So what values I want to give for rancid? I want to give, say, triangular membership function. Triangle means you should specify 3 values. I will say from food quality of 0, say 0 to say 3. Some values I'm defined. So this is my first. I should also specify the range. What range I want. I'll put so rancid. I click rancid again. Define the values what I want. I'll put 0, 0, 2, 3. So now what I have, this is the value for rancid. From 0 to 3, it is rancid. If you want up to 30, I can put 0, 20, 30 for rancid. This is my rancid. Next, medium quality. For membership function 2, I'll put it as medium quality. So again, I have to define. So when I define, I should not again give 0, 20, 30. That is rancid. My membership can have overlapping. I can start from 20. If I start from 20, between 20 and 30, it is both some extent rancid, some extent medium. Just like a person. Some extent you can call him medium height, some extent tall. So normally we prefer overlapping. So what I will give here, I will give some values. So I will put, I'll start from say 20. You can define your own values. Again, I want say 45, 65. I'll just put. So this will be our medium. So rancid, medium. Maybe for good quality, you want to put some trapezoidal or something. So first you give a name, good quality food. I will give some trapezoidal. I can change this also. I can put trapezoidal membership function. I should give 4 numbers for trapezoidal, as we had already seen. So I can start from some 50. I'll put 70, 90, 100. I will define. Now you can see rancid, medium, good quality. So you can see we have defined the membership for food quality. Next, I want to define same way for service. Service also we can say first it is poor. Again, you can define some values, any values that you want. You can start. So I want to define like a triangle. I can also say 0, 10, 40. For triangle, we need 3 values, 0, 10, 40. Okay. But again, before that, the display range should be, you should fix the display range. Otherwise, the values will shift. So poor, 0, 100, 40. Sorry, 0, 10, 40. So poor. Same way we can also talk about next one. Your tips will be decent amount of tips, whatever, because we are framing our own terms. So I will again put some values for decent tips. I can say some 30, 40, 70. Decent. Next, I will say high level of tips. High level of tips, I can define 60, 80, 100. Or 60, I can put some 130, something goes beyond. Okay. All these things, or I can again frame from here itself because I want high for everything else. I can put the same value. We can 60, 100, right? Okay. Next, for tips also, we should define how much tips you want. You want low tips, you can define low. Again, give values. Please, first you could select the range. Whatever range you want, the same range you want to display, you put the range. I've given 0 to 100. You can give your own range. So tips, again, we will now frame. So first one, my tips, what I'm framing is low. Next, I want to frame decent level of tips. Again, some values you can frame. Already some values are given. I'm not changing the values. You can change the values to your comfort. High level of tips. Well, so what we have done now, we have framed the inputs and outputs. Now, what is our next step? Our next step is we should formulate the rules. So what do? We will now put edit. You just see what we next need to do. Before framing rules, we can also talk about what are the properties we want to suggest. We'll say, now we will say, what are the things? We are having a Mamdani model. Edit rules. Now, we have not framed any rules so far. Now this box has come. Now if you see, if food quality is rancid, right? If you want not rancid means you can select not. Otherwise just leave it. And service is poor. Or if you want to put or, you can select or. So we have the options or and not. If food Okay, I'll just show it again. I think it was not displayed earlier. So what you need to do is, I'll come back to this. You go to edit, you go to rules. When you go to rules, well, first delete whatever I've given. So you will have this screen displayed in front of you. So first what you will have is, so now we'll select if food quality is rancid or service is poor. If you want and, you can put and. If you want or, you can put or. Then tips is low. We select add rule. So rule has got added. Next, if food quality is medium or service is decent, you want and, you will put and. Or services and service is decent, tips is decent, put add row. Next, if food quality is good, I don't, and service, I don't want to include this service, just food quality is good. I want to say tips is high. I will just put none because service I'm not including. So food quality is good, service is none, I'll say tips is high, add rule. Now suppose I want only service is decent, I don't want food quality, I'll select none. None is a default option, every time it will appear, even if you don't give. If service is decent, tips is decent, I will say add rule. Like that. Now, one more I will show. If food is not rancid, I've given rancid, you select not. Then if you don't want to talk about service, you just say none. Tips is decent, add rule. So here I have only two parameters. That's why my rules will be limited. You can have any number of parameters, any number of outputs. We will frame all the rules here. Now, if you go to view rules, you can see all the rules in diagrammatic form. This is the place where we can now play with your fuzzy logic. Just keep on simulating. System will do. If you feel outputs are not correct, you change the rules. Our role is only to frame the rules, give it to the system. Now, we have given food quality, service, tips. We have framed 5 rules. So we have 1, So whichever rules, suppose I move this, you see, I move it here. Now you see, this rule 1 is applicable so much. Rule 5 is applicable. 2, 3, 4 is not applicable. Now, if I move this curve here, rules 2 and 5 are applicable. Move here, rules 3 and 5 are applicable. Whatever is applicable, I can show and see in yellow mark. Rule 4 does not have anything about food. So that's why not affected. Similarly, service also I will move. You see which rules are applicable. So I just keep moving. Based on that, it will give the result for tips. You see in the first rule, second rule, third rule, what extent it is applicable. Based on that, the final value of tips, how much you should have, will be shown here. Now you just see, based on that, how I move the line, it is fuzzy. But what system has done, it has done some defuzzification, converted your fuzzy values into crisp values. Based on that, it is giving some value of tips. That value of tips again will be defuzzified. For defuzzification, we can use what is called a centroid rule, which I will just show you at the end of this view. So now we have shown how the rules are viewed. Now you are not happy with these rules. I want to change the rules. Again, you can go for edit, go to rules. If you want to change this rule, service is good. So I want to add something for service here because I have given some none for food. I will give good for food. I will just say change the rule. Now the values have changed. I want to add one new rule. I can add. Maybe the same rule got added again. Food quality is good. I want to add. I want to change the rule. Select the rule and click change rule. So MATLAB will take care of all these things. Your role is formulate the rules. If you think I'm not getting a proper output, you frame proper rules. This is a creativity that you need. You can frame the rules once you are aware of the subject. So that's why I've shown you. So more the rules, it has to do more computation. If your rules are full of garbage, your output will be garbage. How well you have framed the rules, based on that, you can get your results. So this way we frame the rules. You can see the rules. So once you see the rules, you can simulate. This is our simulation. I want to say low service. What should I do? Push it here. Say push the food quality is also low. See what happens to tips. Okay, push it further low. Service is poor. Food quality is also very poor. See what happens to tips. Right? Similarly, my fifth rule is not good. That's why it is showing some tips. So I just push it. Food quality is very good. Service is also very good. Push it here. See how much tips I get. So this mark, you see, it shows the level to which tips should be high. It is actually a fuzzy value. When you see convert, you can imagine some number. Bigger the number, the more the tips you should give. So I will just simulate how much. So I just move. Because I have only 2 parameters, I have only 2 lines. Your real life projects will have multiple parameters. Based on that, you see the tips. Now, one more excellent feature we have in our MATLAB. You can also view a three-dimensional aspect. For that, what we need to do? View surface. Then you can give service on one side, food quality on one side, how much tips we can give. Based on the rules, we can have a three-dimensional view. Now, if you have many parameters, you change. Instead of food quality, you want to give some other parameter, you give service with food quality, see how it looks. Or service with none. So we have both rule view and surface view. So as a brief, since you are new to this, what is that? So before I go back to a slide or something, I will just brief you what exactly you first need. Go to the MATLAB tool, MATLAB. You just open your MATLAB. Just type the word fuzzy. The moment you type the word fuzzy, if you have a fuzzy tool installed, all the later versions, they have this tool installed. Even the older versions are having. So the moment you go to that fuzzy, so what you may be finding is, you will be going into a rule. So you'll be going into a screen which will show inputs and outputs. If I want more inputs, you say, I will add input. So I'll go here, edit, view, 1 second. So I'll put, I want to open, I'll just start new Mamdani, I want to open. So this is my default screen. So what I want to do, I want new inputs, add variable. You want to add inputs, add inputs. You want to add outputs, add variable, go for add outputs. Outputs also I can add. You want to add one more, repeat the same thing. Add variable, add outputs, right? Want one more input, we can add any number of inputs, add, right? Then what we will now, next we will do is, next we want to choose the membership functions. Before that, we cannot use rules. If we use rules, what will happen? It will show, if input 1 is membership 1, you don't know what is input 1, what is membership 1. So first, we should define the membership functions. So we can say, what is your input? Give a name. Name for an input, name for membership function. Now, if you don't give and start, see what will happen. Edit rules. It will say, if input 1 is membership function 1 and input 2 is membership function 2, you don't know what is input 1, what is input 2, what is in. So you should not go to rules first. Define the inputs. So edit. What is the input? Go there. Change the name. What is first membership? Membership is low. Give a value. You select any, you want to select bell shape, select bell shape. Next membership function, select. You want to select what you want to select, go some name you give, medium. Then what membership you want? You want Gauss shape, give Gauss. We have defined only for the first one. Input is low, medium, high. Other inputs we have not defined. So what we should do, we should not come here. We should again go to second input. First, so again for second input also, you define the various parameters. What you have to do, click on that, change. Now suppose you want one more membership function, you can say add membership functions. So how many you want to add? You want to add 3 trapeziums, you give trapezium, click 3. You want to click 2 trapeziums, 2. Put OK. So 2 more membership functions you will add to that input. So we have added to input 3. So that's why you find so many. And once you add, it will give its own values. You want to change, go there and type. So for trapezium, what we should do? We should give 4 values. 1, 2, 4, 5. Now the range you have given is 0 to 1. So all the values will go outside. So what we should do first, change the range. 0 to 10. Now you give the values for the, say I want to give for this trapezium. So 0 to 10 means I will give 1, 2, 4, 5. Now you find the trapezium. But it is showing M of 5. I don't know what is M of 5. So what should I do? Tell what is this. This is low value means tell it is low. Value will change. Like that, we have to define for every membership function. Whatever you define, after that you go for rules. After that, what you are going to do, you can see the rules. You can do the simulation, make changes. Now we have not defined any rules. So when you view the rules, it is empty. Only after defining the rules, you can come here. After that, you can save it as a membership function. You can either import or export. Why you want to do import or export? Some other system you have done. You want to take it from some file, import from file. So it will go to that particular file. So in that any FIS function you have done. Now currently I don't have any FIS function here. So I'm not able to. So go to that default folder. You take that file. So currently I have not saved any FIS file here. So it is empty. So you go there and open. What happens? Automatically that file will come here. And you can make modifications and so on. So this is how you are going to do a basic coding with fuzzy logic. The knowledge that you require is the subject knowledge. You should frame your own rules. Once you frame, give it to MATLAB, do these things. If you don't get, just you can modify the rules, modify the surface, all these things, whatever you want to modify, you can modify. Now I'll just go back to that presentation part before. Okay, I presume we can now see the screen. So the moment I open fuzzy, this is how the things will appear. You have to change the value of inputs, the range. Then we can also use either and or. So we can formulate all these values. So this is what I've just shown. Suppose you want a range from 0 to 3. You should put 0 to 3 in the range box. So I've shown 0 to 100 and 0 to 10. Similarly, I want to define a triangular membership function. I should give 0, 1, 2 means 0 for 0 and 2, value will be 0. For 1, it will be at the peak, value will be 1. I'm defining a triangle. So similarly, so one example I've just sent. For A1, parameter is 0, 1, 2. A2 parameters are 1, 2, 3. So if you see, this is how it looks. Now the important concept here is we are introducing overlaps. This is one concept we have not discussed so far. Now you may ask me, why do you need overlap? Because as I've told you in fuzzy logic, every aspect that we are going to see, it will not be crisp in one particular set. That's what I told. For example, if you want to talk about height, low, medium, or tall. For person, if you say tall to a membership of 0.7, the same person will also be medium height to some other membership value. So here, if you see from between 1 and 2, it belongs to both category A1 and A2. Even food quality, you say, food is good to some extent. You will say, the same food is medium to some other extent. For some extent, I can say food is good. It also tells some extent food is medium. So that is the reason we have overlaps. For good research problems or anything, if there is no overlap, it means at some point value is 0. It is meaningless. So I've shown you how we are defined the fuzzy. I've already shown you in MATLAB how we are plotting. So this is how two triangles we are plotting. Similarly, now we want to plot B1 and B2. B1, I'm giving a range 0, 8, 12. B2 is 4, 10, 15. Range is 0 to 15. This is how it will look when you plot B1, B2. Now I want to perform, next I should frame rules. If input is A1, then output is B1. Here I've shown B1, B2. Here I've shown A1, A2. My next rule is, if input is A1, output is B1. If input is A2, output is B2. So when you see the rules, this is how it will appear. So what is the value of the input? I'm getting the value of the output, which I'll project. As and when I move that red line, my output values will change. You can all try it out whenever you find, if you have your own MATLAB systems, you can try it out. Similarly, I'll now concentrate on the last important aspect which you need to know. That is defuzzification. Your final answer is also fuzzy. Like you will say the tips, what you are going to give is low. This is your final answer. This low is a fuzzy value. But when you give some tips, you need an amount. I will give low. What is low? Low is 10 rupees. Low is 2 rupees. What is low? That low has to be defined. For that, we need defuzzification. We have many methods of defuzzification. Centroid is the most commonly used method of defuzzification. So I've shown an example here. If X is A, then N is D. If Y is B, so this is how it appears in our rules. When you defuzzify, put them together, you have this value. Whatever value that you're showing for D, E, and F, using the method of centroid, it will get one crisp value. It will tell you have to pay 2 rupees 35 paisa. Like that, it will tell. This is the problem we have discussed. An example we just now showed you in the MATLAB. So the service and food quality, we'll call them as antecedents. We don't say condition, we'll say antecedents. The tip, we will call it as consequent. So when we demonstrate, these are the possible. Service is poor, Now I've taken different shapes here, some sample shapes, and I've just shown you a snapshot. Services, food. You can try with different shapes. I've just shown one sample. So if tip is cheap, because of this rule, this is the answer. For second rule, your final answer. Third rule, final answer. Combine all the final answer, we call aggregation. I aggregate all the rules, I'm getting this. So seeing this, I'll say, based on service is 3, food is 8, go and check how much I should give for tips. It will tell tip should be 25, 70 or so on. This is for a general example. For engineers, you can take an example like this. I'm not going to show you a demonstration again. I will show a sample example where you can try it out. Say I want to control the speed of a motor. So what I can do? I can give inputs like very slow, right, too fast. Outputs can be less voltage, no change, or more voltage. What I should do? Rules you can frame. If the motor is running very slow, more voltage. After framing the rules, you should frame the membership function. And after framing, I'll just show how it looks. You should choose the membership function, original set point. People who are in electrical will understand these values, 2420, so on. People who are not into electrical, you take your own example. So I will demonstrate everything. So finally, after framing, I will get some values of outputs. So based on the outputs, whatever tip it is showing 2420 RPM. This is the value no change should be done. So here I've shown 2420 RPM. So my intersection point is 0.4 and 0.3 in this. So if I consider 0.4, so here I will just say, so the triangle area I should know, it will also show how much slowdown I should do. So based on that, I can make a sample, say area, how much area is falling in that place. So this point, you need not worry too much now. People who are into the motor will understand this example. So it will finally produce a crisp value. This calculation is for people to know how the 2.376 is coming. It will directly show you 2.376. Mathematically, I'm calculating. You need not do this calculation. The system will automatically show the crisp value. Defussification will show. So now I will enter into the question answer session. So any doubts or something? So next 15-20 minutes, we will concentrate on that. So that will help me to explain what exactly you want. Chat box. Participants on. So you can type your questions in the chat box. But, anybody wants to ask questions also can ask. Right? You can unmute yourself and ask, or you can type in the chat box. I leave it to you. Any questions? Okay, fuzzy logic controller used. Now, so there's one question. Others can also type the questions. So first thing is, say you want to adjust a valve. Very simple thing. Because when you go into a controller, normally for electronic applications, you can do. Even say for how much I want to turn the valve so that this much amount of water should flow. Sometimes you may find, I want to open a tap. If you open fully, what will happen is full flow will come. I don't want to open that flow. I want water to come a particular level of flow, not very heavy. I don't want to close it also together. How much I should turn the tap? That is the very simplest example you can think of. Same way, people who are working in industry, you want to turn a valve. We take a boiler application. I want to send some steam from a turbine. I want to send it to a boiler. I want to send for some heating purpose. I don't want to open the complete turbine and full steam. My amount of steam I send should be of this level. Suppose more steam is sent, some other problem comes. I want to adjust the exact level of steam. You cannot measure 2.5, 3.5. How to make that adjustment? Any adjustments I want to do is again a control application. Anywhere where you want to, or I will give you a very, very simple example where a day-to-day person goes. You are walking or you are driving a car on a street. When you are driving, you see okay, sorry, I think there was some problem. Okay, so I'll give you a very simple example. You are driving a car, you are finding a red traffic light at some distance. So when you find a red traffic light at a distance, what do? You don't stop there. You slow down, you go up to the traffic light and stop. So when you go up to the traffic light, how long will you go? You don't measure the distance. I will travel 35 meters and stop. You will say, I will go some distance and stop. What is some? It can be small, big, whatever. You don't calculate. After traveling some distance, you have not reached the traffic light. What do? I will travel some more distance. What is some more? How do you find that some more? You simply say some more and you adjust your steering wheel or your accelerator and so on. Suppose you cross the line. What do? You have to come back some distance. So all that some, small, all these things are control. Day to day, when you are driving a vehicle, it is fuzzy control. If it is normal mathematical control, when you see a traffic light, you will say, I will travel 173.52 meters and stop. You don't calculate. You talk in fuzzy terms. You move some distance. You move a short distance. Is fuzzy. This is an application where you are controlling. Fuzzy control. Small, big. You want to control is fuzzy. If it is not fuzzy, I'll say, I will pour 35 mm and stop. You have a definite value. You calculate and do. It's not fuzzy. Whenever you don't calculate, you calculate as fuzzy terms without math. That fuzzy when you say some distance, that sum is converted into 35 meters or 37.2 meters. That is defussification. What is your sum distance you should travel is defussification. Okay. Any other queries? Or if it is not clear, I'll just. No, just see. Is there any Python library? Okay, first thing I will tell, your Python also people are these days, they are doing, I'll not say library, with Python also you have fussification, the function, defussification, that function is there. You just use those functions. These days, people, last 1 or 2 years, people are working on Python. There are terms, fussification, defussification, where you type, it will automatically do further. Just like your machine learning algorithms, it is available. The advantage with MATLAB is you can play with it. Simulation, small adjustment, keep on making small adjustments. You can do fast and exactly you modify the rules. You can play with it. Every time changing a value inside a Python library may be difficult. You simply have to type the word fussification and so on. But the problem in both Python and MATLAB is all are designed based on the expert who has designed them. If you want to make a change, MATLAB provides 20 or 30 different membership functions. Python also provides. You want to define your own membership function, then if you have become an expert, actually when you code, the results will be perfect. But these two, both MATLAB and Python, they have made it enough for a normal or even a MTech level researcher to do an application in using fuzzy logic. Any other questions?
Any more questions? Thank you, Anand sir. It's a wonderful session. Hello. Thank you, one and all. So thank you, Mr. Anand sir. Your extraordinary session, sir. A very informative and very nice session. So from all the corners, all the participants are learning the things, the way we have to be explained is very extraordinary. So thank you, sir. So audience, have any questions from your side? Shall we close the session? Audience, have any questions from your side? Or else we can close the session. Okay, okay. One question. The same question here only. Okay.
I think the same question which was asked earlier. So Python library for, so it is, as I told, both Python and MATLAB have got enough amount of facilities, you have a fuzzification function. Last 1 or 2 years, they are doing this with Python, where your code becomes very short. Up to your MTech levels, this is very good. But if you are trying to create or invent something where your Python or MATLAB and some function, some shape you want to define, which MATLAB doesn't support, then you can do your own code. Fuzzy logic in critical systems. So as I told, so it is not whether system is critical or not. So if you are having uncertainties, if you are having any problem where missing values are in picture, you can use fuzzy logic, whatever may be the applications. If your concentration is more just on accuracy, even if you're, then fuzzy logic may not be suitable. Even then you can go for Sugino model. Your concentration should be whether the application is having uncertainties or whether there are some missing values. In such cases, you can go ahead. Any other questions?
So thank you all. Now we are wind up the session, and I am requesting you, please, all of you be attend at 1:50 for the afternoon session. Exactly at 1:50, all of you, I am requesting you personally, all of you be attend at 1:50 for the afternoon session. And one more request, please, all of you switch on your video. We are ready to take one snapshot along with the resource person. Please, I am requesting you, please, all of you switch on your video for only 1 or 2 seconds. Sir, you minimize, sir. Dear audience, please switch on your video. Please, all of you, please switch on your video. You want to take one snapshot along with the resource person for only for one. Okay, sir, done, sir. Thank you. Thank you so much. So all of you sharp at 1:50, all of you join in the afternoon session. Thank you.
Good afternoon, sir. Dr. Prasad, sir.
Hi, good afternoon, everyone.
Could you hear us, sir?
Yeah, I could hear you. Could you hear me?
Please let me give a brief introduction about you so that you can continue the session.
Yeah, thank you.
Okay, sir. Dr. Prasad Illa, sir, has 16 years of experience in IT and 10 years in applications and product development using Microsoft.NET and open source technologies. He has 4 years of experience in architecting solutions and 6+ years of direct leadership role, and is at present working as a solution systems, Mumbai. We request you, sir, to please start the session.
Sure. Thank you for the introduction.
Welcome, sir.
So yeah, before starting, I just want to know a few things about the target audience, like the programming experience. I mean, because this session is divided into 2 parts, I can make the second part in line to the inputs I receive in the session. So there are 3 things that I need to understand. So who are all attending the session? Do they have any prior programming language experience is one thing. And second thing, if they're into programming, are they into JavaScript programming or web technologies? And do they have any experience in working with modern frameworks like Angular or React? A few of you could just let me know. It will help very much to plan the session. So from where I need to start and all.
Participants can reply in the chat box for the questions. So our participants are mostly faculty. Mostly they are working into the JavaScript.
Oh,
Yes, sir.
So are there any students as well, or all the participants are faculty, ma'am?
Faculties only, sir.
Okay.
They are replying in the chat box also.
Yeah, I hope most of the participants are familiar with JavaScript. Okay. Before starting the session, I'll give a brief introduction of what it means to be a full stack developer or full stack engineer. So it's almost 2 decades earlier, we're into structured programming using C programming language or some scripting languages. It's more of structured programming, and with C++, Java, and C#, we are into more object-oriented programming. So what it used to happen earlier is if an application, okay, let's go by use case. So, let's take an example, for example, like a site like Redbus, which you might, all of you might be familiar with. So if you want to develop a product like Redbus, where travelers, passengers can book tickets online. So earlier, it's like there are 4 or 5 kinds of systems that are in place to develop. After the requirement gathering and high-level technical design and architecture is identified, it's about database developers with the help of architect to design the database, and middle-tier developers, whatever the programming language might be, it might be C++ or Python or Node.js or C#. So developing a backend code which interacts with the database, and also if there are any third-party APIs or web services, interacting with those web services and passing the data to the front-end systems. It might be like web or Windows services or Windows applications. As you all know, there are 4 kinds of applications where a normal user or a technical user can interpret with. So web applications, mobile applications, Windows applications, and service-based applications. As you all know, mobile apps. So there is no, it's like any mobile app, it might be iOS or Android or any other OS app which we use in mobile. or it might be any tablet app, or some nowadays in the smart devices, say like refrigerator or washing machine, we are having the apps. So these are all can be categorized as mobile related apps, and web apps as well, know, which we can browse through in a browser, in a mobile browser, or else PC browser. And desktop applications are such applications where they need some installation, uh, either in Windows or Linux systems, or Mac systems. And service-based applications are those applications which doesn't have UI, so they will be triggered at a particular time, something like cron jobs and all this. And yeah, these are the 4 kinds of applications. So to develop any application, so let me before continuing, let me tell you. So today's session will be more of theory, and the next session will be more of practical. And after giving some brief introduction of the theory, I will just make sure that you all have the environment set up in your laptop or desktop.
Sir Prasad, sir, PPT is not visible.
Yeah, I'll be sharing. I'm just giving a brief introduction. That's it.
Okay.
And so these are the 4 kinds of applications which are in place from the beginning. So what makes a full stack developer different from normal developer is full stack developer will be he will be participating in all the areas of development. It's like a database development, middle tier development, or front end development. It might be mobile development, or it might be a web application or anything. But 70 to 80% of the full stack developers term is defined for web development only. So it will be database plus web services or web APIs plus web development. So let me share my screen. Please let me know if you all can see my screen.
Yes, sir, it is visible.
Yeah, thank you. So yes, we are all discussing about full stack development this afternoon. So I'm taking in case of mean stack. I'm not confining to it. We can if some of you are interested in React, or some of you are interested in PHP, we can apply these basic principles to any technologies. So being full stack developer is a technology agnostic. I'm just taking a case of a mean stack so that it will be easier for us to start. So yeah, yes, in the beginning of the session, in introduction was given about me. So I have 15 plus years IT industry experience, and right now I am working as a Marin and .NET stack architect. Yeah, let's go into the subject. So we need to understand a few concepts before going into in depth of mean stack. So yes, you all might be studying in the engineering subjects of our different architectural patterns, and in the industry on the high level, of course there are so many patterns for each programming paradigm. So if we speak generically, we can make it as two aspects: tightly coupled and loosely coupled. So in this diagram, you can understand like what is tightly coupled and what is loosely coupled. So some two decades or even some 15 years before, systems are developed a way where they are very much tightly coupled, where extension is not possible. Either they are forced to rewrite, or else there might be a lot of effort required, or the systems might be stopped if there is something needs to be added. There is nothing like you just plug and attach. So the systems are mostly developed using one or two technologies. For example, in earlier days, most of the applications are developed in C++ or VC++, all the softwares that we used to install in the desktop. And websites, they used to have HTML. It's not even ES6 with the ES6 standards. HTML, CSS, and just plain JavaScript. Later, jQuery played a prominent role in bringing new frameworks. So as you can see, tightly coupled components are built into a fit a singular purpose, and are dependent upon each other, and they're not easily reusable. It's the main drawback of this type of architecture. So they they centralize the core business logic and start building walls between them. So no, you can't really, if something is changing tomorrow, or you need to talk to third-party systems, this is being very difficult. So this is the type of programming paradigm that was used earlier. But very rarely we can see this type of architecture now. Almost more than 95% of the applications, they are very much into distributed systems, distributed kind of architecture. They're loosely coupled in nature. So, and also, if you name any application, it's not based on single technology. For example, as I said in the beginning of the session, we can go by use case. What we have taken is something like Redbus. Redbus is having a web application. It's having mobile apps, both iOS and Android, and there might be some applications for backend dashboards for its employees, and partner portals for the travel agencies. So altogether, there might be some more than 10 applications, because it's a very much active application where almost thousands of tickets are sold every day. So they need to follow all the backup mechanisms, and they are in cloud. So you name it, there are a number of technologies that are being used for one use case. They are into cloud. It might be AWS or Azure. They are into some backend programming APIs. They are consuming third-party APIs. For example, they are using, for example, Paytm for the payment system, or PhonePe for the payment system. That means they are consuming third-party APIs, and also they are providing the APIs for other services to use those. For example, if you talk about a movie website like Cinepolis, so I know the Cinepolis because I have worked with Cinepolis for one of the clients, where we can consume Cinepolis web APIs or web services to compare the ticket status at a particular theater for a particular show for a particular movie, and get the status, and we can even book the tickets, and we can print the tickets. All this is done from a third-party website. It might be my personal website which I'm building. If I have partnered with Cinepolis by paying the developer fee and all, I can do that. I can do it straight away from my website. But what we have developed is for a different business. It's for employee reward system. So where the employees are getting rewards, and that rewards can be consumed to purchase movie tickets and all. So either you take a Cinepolis or Redbus, they are not relied on a single technology. They might use JavaScript-based frameworks like Angular, React, or Ember, or a different thing for front-end development, front-end web development. And for programming, it might be Ruby and Rails, or Python, or Java, .NET, or Node.js. And for database, it can be any NoSQL based database like Firebase or MongoDB, or a relational database like MySQL, Oracle, or SQL Server. So if you take here, the takeaway is, if we consider any single application, there are a number of technologies. Why we are discussing this? Why we want to know there are a number of technologies involved in an application development? Because being full stack developer is not that easy. We need to have at least intermediate level knowledge in all of the technologies that are being used to develop the application. So if we want to build a robust kind of application, for example, in mean stack, we need to have knowledge in the whatever first the database that we have selected, might be MongoDB or Cassandra or DynamoDB or Firebase based application, might be Firebase based application, or we might even jump into MySQL. For the practical session, we'll be selecting any of the technologies which you already might have knowledge on, and we'll be working on that. We'll be working on a simple application if possible, or else I'll be sharing the code with you. So after the end of the session, end of the second session, so that you can explore that in detail. Because I'm trying to cover all the high-level aspects in these two sections. It definitely takes in the earlier programs. It used to be like a 1 week workshop for full stack development. And there we have time to install on each individual's laptop, and we used to run the first programs, taking much time, like first 2 or 3 days. It's like running the first set of programs and connecting between the APIs and front end. And by the end of the workshop, each and every participant were in a position to start a new application, and sometimes we deployed on free servers as well. But now the emphasis will be on understanding the theoretical part for today, and after the end of the today's session, I'll give you the list of technologies that you may install. It's not very hard. It's very easy. All are available very easily, and those can be installed through commands. Some of them can be installed through commands. So, and it will be easy for if you have completed the installation, and for the next session you have the environment ready. You can run the application and feel yourself by playing with it practically. So that is a whole agenda of the 2 sessions. And where I have stopped is we need to have skills on multiple technologies to be as a full stack developer. So it might be database for programming, a middle tier programming language skills, and JavaScript based. As I said, almost 80% of the full stack development will be into web technologies. There are some areas where people ask for Laravel plus PHP for a full stack developer, or UWP apps like Universal Windows Programming apps, which are XAML based applications for developing desktop based applications. But the ratio, it's like the percentage is like almost 80% of the percentage is for web applications. And in the web applications, there are 4 major players, like a plain JavaScript clubbed with different JavaScript libraries, and Angular, React, Vue.js, and there are some other players like Ember.js, and so on. I'll give a list as well. But if you see for any new project, there's a debate between Angular, React, or Vue.js. So based on the availability of the developers, based on the budget of the client and the time frame, and considering the libraries that and third-party library support, and all this, and the basic nature of the application, this technology is selected and implemented. But you can think like out of the JavaScript technologies that are being used, the modern framework JavaScript libraries, 80 to 90% only these three technologies are being used: Angular, React, or Vue.js. Again, for each of these technologies, they have some supportive third-party libraries. When you go in depth with the technology, when you travel in depth with that technology, you'll come to know that these 2 sessions definitely will give you in-depth understanding of the basics and how to start learning on full stack development. So feel free to ask me any questions, or you can send me in the chat notes. Understanding the basics is very crucial. The first steps should be very solid. Some of you might even get bored because you might have already learned, or you might come across these all these basic things, but I'm not sure for if each of you are much aware. So as my duty, I need to focus on basics first, so that if the fundamentals are very much strong, that what is the core concept of full stack development, why we need to concentrate on multiple technologies, what's the basic architecture, and all these. If you understand, so you can select a technology and you can start with it by all the basic knowledge you can get from YouTube. That's for sure. But understanding the concept, why you are going to full stack, this explanatory session should give a the path for you to travel in this full stack development. Yeah, and coming back to this slide, as I have mentioned, for the loosely coupled architecture, if it is you can see the boxes like some are in square, some are in round, some are in hexagon, or some a node with red color, which clearly indicates its core part. Now it's decoupled or loosely coupled components. Each of this is a component, and for example, the component which is a square, it might be in a it might be a backend component written in C# language, hosted somewhere in hosted as an Azure function somewhere in Azure cloud. Okay, and the other hexagon might be a Node.js based web API hosted in somewhere in AWS, or the database might be hosted somewhere in GCP, Google Cloud Computing. So nowadays, most of the systems are distributed systems, and almost the applications are deployed in cloud, because maintaining in-house servers is a costly affair, and also not vertically scalable. Not only vertically or horizontally, it's not that quickly scalable.
What is the root node? And the three order we can able to find the right.
Srikanth sir, you're asking me something?
First order and in order.
Yeah, probably some unmute might be happen. Okay, let's continue. So you're all able to listen to me again, right? Can someone, at least one of you, answer? Yes. Okay. Thank you. Thank you, Seth. Okay. And it might be in the cloud, so we can rarely find applications which are hosted in house, except for some highly secured banking applications which are hosted on their highly secured internet servers. So we need to understand the cloud concepts as well, the basic cloud concepts, so to be a successful full stack developer. You were carrying four developers responsibility here: backend developer, front-end developer, middle tier developer, and DevOps engineer. At least the basic level of deployment. We should be able to understand the basic level of deployment. So here, as I said, we are going with mean stack. So mean stack stands for MongoDB, or you can some people might go with MySQL. And E is for Express.js, A is for Angular, and N is for Node.js. So Express.js is a framework which is on top of Node.js, which is used to express, which write relative code for web APIs using Node.js. So what you'll be learning all the basic concepts to build real Angular Node.js applications, understand how the Angular works and how it interacts with the backend, connect an Angular front end with Node.js backend. And we can either go with MongoDB or MySQL. Again, I'll take inputs of you at the end of the session, or else the main problem here is it will be very difficult if each of us maintain a separate database. So what I can do is I'll try to get some access to a cloud server where we can have some, for example, a MySQL database, and you can try to each of you can have access to special in something like a user can be created and shared to all of you so that you can have access to the database. So it will be a single database, so that we need not worry about the structure, the data structure. If the data structure differs, again we need to change the APIs. If the APIs changes again, the API consumption code should be changed. So believe me, it is going to be very easy for all of you. It's just after today's session, with few comments, a few installation steps, you will be completing the installation and just creating the application. It will be very easy. Yes, it's like a big ocean, but the baby steps are easy. Continuous learning is always required, but I'll make sure that you'll have a smooth start. Some of you might already be into this, so it helps for you to revise again, or else you can help your colleagues on that. So yeah, we can make a decision between MongoDB or MySQL. Again, when it is coming to Express.js, it's a Node.js framework. It provides a great user experience by using optimistic update on the front end. It's about Angular. So Angular provides a very good user experience. So you can't see like a page is refreshing or something like that. On the fly, you can see like the data is changing and all this. So it's a component-based architecture. Yeah. If time permits, we'll also see error handling, something like that. But actually, this is my vision to make you able to develop one complete application. But yeah, we do have time restrictions. But even if we do have some time restrictions, what I could probably do is this weekend I can spare some more time for you, and I can collect your email IDs and share a GitHub link where I can upload all the code, so that you can continue learning on that. So here practically what I am trying to do is develop an application on Angular. You can do some steps, things like image upload. Again, to upload on all this, we need a server. It can be AWS or a Azure based server, or if not, if we want to stick locally on your system or desktop, all this image upload can happen to a local folder. And of course, pagination, authentication, and authorization. I said it will be good that we all connect to a single database, and we can fetch the data, and we can implement pagination and authentication. And so how to control the only users who created some content can edit or delete. Basically, it's like a authorization concept. So, and deploying to one or more servers. I'm not sure if you all have any cloud credentials. Can someone reply whether you have any cloud AWS or Azure cloud account? Some credits. So no, okay, fine. Yeah, it's always possible to create a free account if you want to explore furthermore. It's a free trial given both by AWS and Azure. Azure gives for 30 days. And AWS also, yeah, it gives for some more extra period. And some of the services are always free in both the cloud. AWS and even GCP also provides, but mostly AWS, 70% of the market is occupied by AWS and Azure. And if you want to make a good career understanding in that and teach your students all the new concepts, so you can try practicing either of these two cloud-based systems. Yeah, that's about deployment. It's not mandatory to do the deployment, but I'm just giving the complete life cycle of a full stack. So right from design, requirement collection, designing a system to deployment and maintenance. So I will, it's like covering on the high level so that whatever and where you want to pick up, you can always do that. And these are basic requirements that are being expected, but need not be confined. If it is okay, even if some of you doesn't have that level of experience, because this is very basic level session where I'm trying to give you complete understanding from the programming concept, from the architecture concept, and about front end and starting with it. So you can always just raise your hand and put your question so that I can explain again. And so concepts behind the Node.js Express and MongoDB will be refreshed, but it's the focus is only on connection of these technologies with Angular. Angular would be the basic web front end. So basic knowledge on them is strongly recommended. We use those mostly for connecting with Angular. So it's recommended to have some beginner level knowledge in Angular. But yes, some of you might have already replied that you are already having some knowledge on JavaScript. So it would it really helps. So I would take some give some basic explanation of Angular as well, so that it will help you to start on it. So having JavaScript knowledge will be very beneficial, and HTML CSS knowledge is expected. Actually, it's a minimum requirement, so that we need not focus again on HTML and CSS concepts, as this session is not targeted towards the basic web development. It's more of full stack development, right? And in the full stack, we have taken a case of mean stack. It's like a big version. In the big version, we have it's like 7 versions, and we are confined to 1 version. So, but no advanced or expert level knowledge is being expected in these sessions. Yeah. So we have taken the case of mean stack, and again database part we can either go for MongoDB or MySQL, but the rest of the things, Express, Angular, and Node.js will be as it is. So just if for anyone who is listening this technology for the first time, just spend some 10 seconds and try to take the screenshot. So you should know what you are going to learn, and after that, this is a keyword, this is a buzzword, mean stack. When you're talking about full stack, it will be like mean stack, meron stack, or lamp stack. So you just keep these buzzwords. So just take a notes of it. Yeah. And we're starting with what's Angular now. So in the mean stack, there are 4 things, right? In the previous slide, you can see one is for database, one is for Express.js, and Node is for middle tier, and Angular is for the front end. So in the front end part, we are discussing about Angular. Angular is a client-side framework which allows to build a single-page applications. So single-page application is a web application where we don't see like a page is moving front and back. So everything is presented in a single page, but while programming, we are organizing that into multiple HTML pages. We call each of it as a component. We might have 100 components. In theory, these are 100 different HTML pages, but these will be rendered into a single component. Single page, for example, index.html page. And in the same page, we will be rendering all these components. And we can define routing. Again, it is optional. Routing is like where we see the address in the address bar. So, for example, if you say we're making a website for ticket booking, like say mybus.com. So mybus.com/tickets. That tickets is the routing. So say mybus.com/history, where we can see all our transactions. So that's the routing again. But even though there is routing applied, Angular is meant to be a single page application. So routing is again optional. Some applications will not have routing. Some applications might have. Some small applications or some gaming type of applications that they don't have routing. So the main advantage of Angular is like it's render UI data with dynamic data, render UI. So in the UI, the general HTML controls, we see text boxes, labels, paragraphs, which represent static type of data, and tables or list boxes, which sometimes represent dynamic type of data. You know, all these whatever the component which we render in the UI, that can be clubbed with dynamic data. And the second thing is like handling user input. So it might be any form of input like text boxes, drop down lists, multiple choice boxes, or you can say paragraph or type for text areas. So in any form, whatever the radio buttons or checkbox, whatever the input form we take, we will be handling the user data into objects, and we will be storing into the backend database. So handling the user data would be very easy with these kind of frameworks, Angular or React. Here we are talking about the use case of Angular, and communicating with the backend services with the help of HTTP protocols. As you might have already know, there are different types of protocols, right? Like HTTP, TCP, or some messaging systems like MSMQ, RabbitMQ. So most often we use confine ourselves to HTTP or HTTPS protocol. So it's a most universally accepted protocol. Okay, and so it will be very efficient and useful with the help of Angular to communicate with these backend services. And another advantages like like it provides a mobile app like user experience. Angular provides even if some clients ask us to develop applications which just look like mobile applications, but they don't really want to invest on separate mobile apps. So this website can be browsed to be a mobile app. That's about Angular. Again, we'll go in depth of it. So and the coming to the server part, the middle tier, Node.js. So what's what Node.js? Node.js is a server-side library. So when there is a competition between browsers, in the earlier days, it's more of Mozilla Firefox, Opera, or Internet Explorer, and some other small browsers. But the invention of Google Chrome, things have changed a lot. It's about in 2008 or 2000, between 2008 and 2010. Google Chrome was in beta phase, and they have used an engine called V8 Chrome engine. So V8 Chrome engine played a crucial role in developing Node.js. It's like earlier JavaScript is used only for web technologies, only for web pages development, nothing more than that. But with the advent of Google Chrome and Google Chrome's V8 engine, that is an open source engine, and it's used in different libraries. And one of its founder, Node.js founder Adolf, he used it and developed a programming language with a JavaScript-based programming language using Google Chrome's V8 engine. So after 2 or 4 years, some standards were established, and slowly its adoption increased, and it had grown very fast. It had grown very fast, and today it's one of the leading backend programming language and scripting language, not only web applications, service-based applications, and for the middle tier, Node.js is being the ultimate choice. There's so many advantages of it. It's quick to start. We can always have toppings. Here, the toppings I mean different frameworks. Just like when we're ordering a pizza, we'll be having an option to add a topping regarding cheese or any veggies. So just like that, based on our requirement, we can go for different frameworks. Express.js being the basic level of framework. Some alternatives like Sales.js, Happy.js. These are all other topics of Node.js framework. For some efficient efficient protocol systems or secure systems, or something like Passport.js to handle all the authentication mechanism. Filesaver.js to handle file download. And when we talk about Node.js, it's not about a single time installation, and we are going to command prompt and we are executing Node.js. It's not that. Based on our requirement, we'll be using third-party applications. there are lakhs of Node.js packages. We need to understand something about NPM, which I'll be explaining after this slide. So we'll be using here Node.js to listen the requests and send the responses, to execute the server-side logic and interact with database and files. Database, for example, to fetch the data. For example, if you are building any travel bus ticketing system to inquire the leftover seats, to inquire the booked information and etc. We will be interacting with database, or else downloading the ticket in a PDF form, or uploading the identity. If there is a requirement, like we need to upload while creating the account, we need to upload our government ID proof. So it's like image upload or PDF upload, and we will be storing those files on a file server. So all this is handled by Node.js. So alternative for Node.js are like PHP, Ruby and Rails, Java, etc. And Node.js can be used as standalone, but it's very rarely used. It's mostly used for development of web APIs. And Express.js, it's a Node.js framework which simplifies writing server-side code and logic. Even we can do all this HTTP programming without having Express.js, but it really makes life very easy. Somewhere where we need to write extra 10 lines, that can be written in just 1 or 2 words or 1 line of programming. So it's based on Node, offers same functionalities as Node offers. It funnels requests, like funnel is like some you're pouring something into a bottle of small mouth. So we use funnel, right? We're pouring so much of information, but the flow will be organized manner. It will be in an organized manner. So all this, how it is organizing is through functions. So again, it has some advantages like built-in lab routing, rendering. You can even without front-end programming language or basic JavaScript, we can render the HTML content which needs to be displayed on the front end from the Node.js backend itself. But we rarely do that. Yeah, some applications have that purpose, but we're not going to be traveling in that path. But because it is its use case is very limited. Mostly will be all this front end will be developed in any of the framework which we are going to choose. In this case, Angular. So Node.js, Express.js simplifies the usage of Node. Express is for Node, and what you can say Laravel is for PHP. If you are working on PHP desktop applications, you have a framework called Laravel, which will be used to work with simplified PHP. It comes with a lot of extra libraries. So there are other alternatives for Express.js, like Sales.js and Happy.js. Yet let's not go in depth into MongoDB. Yeah, we can either use MongoDB or MySQL. I'm sure almost all of you might have understood the concept of database while teaching. Some of you might teach database DBMS subject, relational database management system subject, either with Oracle, or sometimes you might go with the SQL Server. But the whole concept is the same. It's for database management. It is not mandatory here to understand either it's a relational database or a NoSQL database. But the concept you need to understand is what it's a database management, where we will be having some tables and queries. It might be a normal query, or it might be a stored procedure, or we can use some functions. That's it. if you are going with NoSQL, we'll be using, we'll be calling those as collections and all this. Documents is like, we use, if it is NoSQL, we use the terms like documents and collections instead of reports and tables. So I'll try to find out if I can get one centralized database server and create a user and share it with you. So we can, it really helps. It saves a lot of time where we can quickly jump into the purpose of learning full stack development instead of focusing on the details like installation, creating accounts. Again, sometimes it'll throw a number of problems. For example, we have around 60 plus audience here. We might land up in having some 30 plus problems, and there is no real meaning in dealing with this in these sessions, right? So, but you can always, just email me while you are practicing if you are facing any trouble. I would like to help always. Yeah. So before starting the next session, I'll give you an update on that. I'll try to have some centralized server. If not, I'll give you a PPT on that, how to install or in an easy way. But I advise you, all of you, to create an account in Oracle and download MySQL. MySQL Community Edition. So if we are not able to manage a centralized server, we can quickly, if you have already downloaded and installed, you can quickly create that same database all of the systems with by sharing the script, by sharing the SQL script, and we can be operational. Yeah. As anyway, we have come across this slide. Let's just go through what really MongoDB is. MongoDB is of NoSQL database type. We are having this NoSQL kind of database since a decade more into the market, where it's different from a traditional database, relational database system. There are some power, some advantages with the NoSQL. It's like it is easily connected to these frameworks. Main advantage is like they don't enforce any schema or relational rules. They can always be, it's like a vertical expansion kind of thing, where the data is stored in collections in the form of JSON. So something like an example, if there is a user table, we can say it collection of users, and if there is a person called Ramakrishna, instead of record, we can say record in the normal relational database system, and we can say a document of Ramakrishna, where we can pull the particular fields JSON, and it's always there is no restriction like there are two records. A JSON of record one should be as similar to record of second document, but it's not the same with RDBMS systems. If we define a schema, if we define a field length, we always our field type, we always should confine to that. For example, if we are creating a user table and say user ID as a type of string or varchar of size 50, so here we are imposing a restriction of whatever the value we are giving in the field user ID, it should be it can be a number of string, but the length should not be more than 50. Suppose if you have a restriction like it should be in integer only, then we can't give any alphabetic values as input. We should be sticking to integers only. So the main advantage is like when we have so much of dynamism, it's always helpful, and it's always help. It really helps for quick development once we understand the concept of MongoDB. Yeah. But again, we can choose between these based on the availability of some centralized server. So this is the bigger picture of mean. So just to spend some 1 or 2 minutes looking at this diagram, then I'll be explaining this. Yeah, hope all of you have understood some part of it, and let me explain this now. So when we are discussing about web-based systems, always there is a browser, or where we can call it as a client. Even if it is mobile-based system, the mobile app is a client. The browser can be either from mobile or from tablet or from laptop or desktop, basically a computer. It might be from computer or from mobile or tablet. So when a request is passed from a browser, so which is referred as client, it will receive to the server. Here the processing is done through Node.js server, and it can be hosted in this on any cloud, on any kind of server like IaaS or NGINX or Apache. But the deployment process on each of the server is a little bit different. Some some tricky parts will be there with some servers. But for most deployment scenarios where Nginx on Linux is used, it's always economic to go with Linux type of deployments rather than Windows. So whenever a request is received through a client browser, it is sent to the server where Node.js server does the processing. Node.js server here runs in a particular port number. By default, it would be 3000, or it can be anything that we choose to give. And what Angular does is it will take care of all the presentation and UA part. As we have discussed, it's a single page application. And single page is not necessarily served by Node backend. It only passes the data. Rest of the thing on the presentation, organization of the components, layout, everything is handled by Angular. Coming to the server part, we write all the business logic in Node.js code and persistent data storage. Like we can be using any kind of database, MySQL, MongoDB, or Oracle, or SQL Server, or Postgres. Irrespective of the database that we are using, So we can simply call like we're using some persistent data storage. Any code relating to authenticating the storage, querying, that is querying the data, and after receiving, formatting the data, and all this is handled in Node.js code. And all the authentication logic, basic authenticating using the JWT tokens, and each time checking the expiration of the tokens, passing the refresh token. All this will be handled by Node.js. So what we can do is we'll proceed to in the next 15-20 minutes. We have another say max 20 minutes to half an hour. I would just want to make sure you install all the required software. So in your laptop, if you already have, it is okay. But if you do not have, just visit nodejs.org. And when these slides are prepared few weeks before, this is the version, the LTS version. So always try to stick with LTS version. There is no issue if the version is changed. So go to nodejs.org site, download it. It hardly takes 3 to 5 minutes. In the next step, we are going to install Node.js and also install Angular and Express also. So once you're done downloading, some of you can, I understand, as I also attend meetings, the sessions online. We cannot expect everyone to reply because everyone will be busy in either just doing this process, or they might be having some other priority work and keep an ear on session. So some of you can reply. We can just allocate some 3 to 5 minutes for this to download. And after you have downloaded, we can proceed to installation. Yeah. Thank you for the reply. So after downloading, can you just click on it and go for installation? It's a simple step, simple process. You can just click on next and you can complete the installation. Okay, thank you for that. So as you are able to install a complete node installation, just open a command prompt and type node. As you can see in the screen, just type node so that you can get something like welcome to node.js and the version number that was installed in your systems. And here you can type something like 2+2 and say enter, you'll get the output. So that node is doing using the math libraries, it is performing and giving us the output. Or else another way is you just come to control C again. Say node minus v, node space minus v. It will give the version of it. Okay, fine. It should welcome to node. Good. So another thing that probably you need to do is npm space minus v. So we need to make sure that we have installed npm also. It comes by default with node, but sometimes if there are any issues installing the npm, we can't proceed to the next steps. So make sure we are having npm version as well. Okay. Sometime back I have mentioned you that I'll be explaining about NPM. So let me share the browser here. So NPM is Node Package Manager. NPM stands for Node Package Manager JavaScript libraries. So you can search any packages. Like for example, I'm typing as file. Although file library related packages can seen here, and it shows what is a command to install that particular JavaScript library, how to use it, and the repository GitHub link for that. If it has any homepage, the homepage, the statistics of weekly and the total downloads and the collaborators, and the API or the documentation part of it with examples sometimes. For example, when you do dealing with time related libraries, there is a library called Moment.js. Here, you see the documentation, it's being redirected to Moment.js website. When we are dealing with time and date functionalities, Moment.js is highly recommended. The same way, Angular is one library. There is another package manager which is called as YARN, but mostly NPM is used. Again, it's optional. You can use anything, but the commands in while you're using yarn differs. So here you need to understand what about Angular CLI. Angular CLI is the command line interface. So if you're talking about any framework, there will be some commands. For example, you can talk about Unix, the bash commands, or in the Windows command prompt, basic commands like cd for changing directory, md for making directory, dir for listing all the files in the library. So these are given by default with the operating system. But if we are using any third-party application or any new software, it will have its own set of commands. For example, there is the AWS command prompt SDK and Azure SDK command prompt CLI SDK. So they have their own set of commands. Windows PowerShell, it has its own set of commands. The same way, Angular CLI. So which will be having its own set of commands which related to Angular. To create a project, to add the few libraries, and to run the application, and to run the application in some configuration mode, to do the build for deployment, etc. We will be having this command. So I suggest you all just execute in the command prompt, run this command npm space I space @angular/CLI. There are two ways that you can do it. This is one way, and another one is by going through to Angular website. The Angular, the site, the URL path is angular.io/CLI. So this is the command. See, there is a difference between this command and what you were seeing in Node npm.js website. Here, extra switch is there like -G. It is it indicates that we'll be installing globally all these Angular CLI so that it will be available to the user, and from he can work on Angular from any of the directory or any of the drive. Suppose if you are in Windows, it might be C drive or D drive. You can create a new folder and open it in command prompt and execute Angular CLI commands if you install this globally. Or else it installs locally, and in that particular folder only you'll be able to execute this command. So I advise you to use this command to install Angular globally. The command is npm space install space -G space @angular/CLI. So take some time, a couple of minutes, and just let me know on the chart. This is a very important step to proceed to the next session. So once you complete the next step would be like we would be creating an Angular application, just running it if possible, and then closing the session for today. And in the meanwhile, if any of you haven't already done this downloading Node or installing Angular, you can do it and be ready for the by the time we start the new session. And most importantly, if you're having any doubts, the last 5 minutes will dedicate to clear the doubts. So take some time and install Angular.
Thank you, Prasad sir. It is a wonderful session. Audience, have any questions from your side? Please raise your hand or post your question in chat box. Audience, if you have any questions, please raise your hand. Otherwise, post in chat box. Have any questions from audience? I think no one is ready to ask the question, sir. Prasad sir.
Yeah, no problem, sir. So let them take some time.
Okay, okay.
So,
Sir.
Yeah. So for the next 5 minutes, we can just be on mute and wait. So let them either install Angular and either install Node.js and complete installing Angular. So that because this in the next session will be with, completely practical session. Um,
Okay, sir. Tomorrow, na sir?
yes, sir.
Tomorrow morning session. Okay.
Yes. So it would be completely practical session, and I would suggest each of the interested participant to install till this step. So in the next tomorrow session, we'll be creating some components and do some Angular coding. So to facilitate that, we need to complete till this step. So next 5-10 minutes, we can just be on mute and wait for the participants to complete till this step.
Okay, sir. Okay, sir.
Thank you, sir.
Audience, please, feedback will be shared in the chat box. Please fill the form and submit on time. Prasad sir, if possible, share your PPT, sir, to convener, sir, mail ID.
Sure, sir.
And installation process also be sent to convener, sir.
Yeah, sure.
Students are asking.
Okay, sure, sir.
If participants, if you want to see the information regarding the installation, and you watch the YouTube.
Sure, I'll be sending the content related to me also. If any of you are getting errors, just take a screenshot. Probably I'm sharing my mail ID here. I'll be active and checking the mails regularly so that I can answer you. Okay, guys. So the question is, do we have to install both Node.js and Angular? Yes, we need to install both the Node.js and Angular. First, we need to install Node.js. Just verify opening command prompt and typing node and make sure you're having a version number. And once you make sure node is installed, then run this command npm space install space -g space @angular/CLI, and you should be able to install Angular CLI in just some 3 to 5 minutes time based on your internet speed. We need to install both Node.js and Angular.
Participants, any other queries you can ask, or you can put in the chat box. Any other questions from participants? You can also note down the resource person's mail ID, which he has put it in the chat box. You can contact him in future also in case of any clarifications.
Yeah, thank you, one and all. So just make sure that you'll be having the environment ready with Node.js and Angular. So it's not really mandatory to attend tomorrow's session, but it will be very helpful to you if you are doing a parallel programming, like along with the instructor. If you're able to get the same output, it boosts your confidence. And if you have any doubts, you can ask on the fly. Sometimes we might be getting a number of errors because while working with programming, we are always thrown to errors, and errors might not be the same for each and everyone, right? So try to be with it so that if we get more errors, it will be more learning for us.
Okay, before leaving, all the participants, you're requested to switch on your videos, have your at least online photograph along with the resource person. Kindly switch on the videos. One second. Participants, kindly switch on your videos. Yeah. And all participants, before leaving, kindly assemble by 9:50 a.m., 9:50 a.m. tomorrow for the session. So the resource person will be continuing your hands-on session. So kindly be available by 9:50 a.m. tomorrow. I thank you one and all for the cooperation extended to us.
Thank you, one and all.